And this is a very good question for understanding the structure of a function, the composite function, and the chain rule, and so on. Okay, that we're given y is equal to log x plus root 1 plus x squared. F of y is square root 1 plus x squared. We are looking for the second derivative of f with respect to y. And also that find the f of y in terms of y. This is a very, very good question. Now let me start this one. Okay, first we're given y is this function, therefore we can find a dy dx, which is equal to x plus 1 plus x squared, right? Multiplied by the derivative of this, which is equal to 1 plus 2 square root 1 plus x squared 2x. Then we can simplify. This one is equal to 1 plus x squared. 2 to cancel out. This becomes this. And this is 1 plus x squared plus x, right? Therefore, this cancel out is equal to 1 over 1 plus x squared. So this is dy dx. Okay, then then we come to this one. F of y is equal to square root 1 plus x squared. If we want take the derivative with respect to x, both sides, the left-hand side will be what? Okay, let me repeat again. We are taking the derivative for both sides with respect to x. So the left-hand side will be, but don't forget that f of y is a function of y. F of y is a function in terms of y. So when you take a derivative with respect to x, it has to take y first. See, then dy dx. That's called chain rule, right? Now I'm taking this one, the derivative with respect to x. That will be this. Okay, then is equal to that side is obvious that is equal to square root 1 plus x squared and 2x. Correct? Yeah. And since this one is this, so df dy 1 over 1 plus x squared is equal to x over 1 plus x squared. See, this means that dy df dy is equal to x. See? Interesting. The derivative of f with respect to y will be x. Is x, yeah. Then for this one, we are take derivative with respect to x again. Okay, now let me repeat again. We are taking derivative of this equation, both sides, with respect to x. But don't forget that this is a function of y. So when you take a derivative with respect to x, you are using the chain rule. First, you take this derivative with respect to y, right? take this derivative with respect to y. Then the chain rule, take the derivative of y with respect to x again. And this side is equal to 1. See, that is the derivative with respect to x. So, okay, this is the second derivative of f with respect to y. This dy dx is equal to, I know that is equal to this, right? 1 plus the square root x squared. The right-hand side equal to 1. So this gives us the second derivative of f with respect to y is equal to this. See, that this is a very good question. So we find this one. That would be this, because the product is equal to 1. That is the first question. We have found the second derivative of f with respect to y is this, just in terms of x. Okay, this is the first question. Now the second question, it is only for those who learn differential equations. Okay, let me do the second part. We're looking for f of y in terms of y. Okay, now we know that this is a second derivative of f with respect to y. We also know that this is f of y. They are equal. They are same. So we have a differential equation that is a second derivative of f with respect to y is equal to f of y. Okay, this is second derivative. That is f of y. Okay. Now, if you learn differential equation, that means the f double prime minus f of y is equal to 0. Okay, let me write this way. Okay, the second derivative with respect to y minus f of y is equal to 0. Then the characteristic equation, that is r squared minus 1 equal to 0, right? Therefore, r equal to plus or minus 1. This means that f of y is equal to a e to the y plus b to e to the negative y. Okay, so that is the equation. That is the answer for f of y. But we have to determine a and b. Okay, now how to determine a and b? From this. Okay. Now, from this one, we know that when x equal to 0, y will be log 1, right? So log 1 is a 0. So this means f of a 0 is equal to a plus b. But we know that f of a 0 when x equal to 0 is equal to 1. So this is equal to 1. From this, we know that is equal to 1. Also, we know that the derivative, this first derivative, when x equal to 0 is a 0. Y equal to 0. So this means that we take the derivative. This is equal to a e to the y minus b to the e to the y, negative. And f of when y equal to 0, this will be equal to a minus b equal to 0. From these two equations, we can find a and b is equal to half. See, it's very good. Therefore, our function f of y is equal to 1/2 e to the y plus e to the negative y. That is the answer for our second question. Okay, this is extremely very good question to practice, to understand better the functions and its derivatives. Now, okay, I'll leave the verification for you, for yourself. Okay, verify that uh, the f of verify this equation by putting that all the data, in, and you can easily do that verification by yourself. All right. Okay, I leave the verification for you to for yourself. Thank you for watching.